This is the real Tom Rose, and we need to do a little bit of function building to solve this problem. Now, it helps to start out with an understanding of how quadratic equations make parabolic graphs in the first place. And let's draw some axes and start out with a standard y equals x squared equation. Now y equals x squared is going to look something like the following. All right, it's a parabola that has a vertex at 0, 0, and it proceeds up in both directions. Now, let's take a look at what happens when we make some changes. If we add a number across the board, so just take the regular function and add 1 to it, what you do is you take everywhere where you had a value for the original equation, you'll still have a value, but it'll be 1 greater. So I'm drawing dots 1 above all the other points in this function. So what we end up with is a function that looks like this. If we were to, say, subtract 1, we would end up with a function which moved down. So if we want our function to be below, to have a vertex below the origin, we need to subtract something. And since the function that we've been given is f of x equals x squared plus a, we know that this value for a must be negative. Which is what answer choice B says. Even and odd would just determine whether you move the function down an even number of grid lines or an odd number of grid lines. So those are both out. A perfect square is irrelevant, right? If you move it down, if it's a perfect square, so a is 4, for example, this would be moved up by 4. But that's not a requirement. And if a is positive, you get a function which moves upward. So we're dealing with B.